Hi, this is three-phase full converter. We will see now three-phase full converter as in inverting mode. For firing angle 90 to 180 degrees, full converter acts as inverter. So inverting mode means output voltage is negative, current is positive, so that power flow is from load to source, right? So in rectifier case, power flow is from source to load. Inverting mode case, power flow is from load to source, right? So for I will select firing angle 150 degrees so that we can find firing instance for thyristors. For T1, alpha plus 60, 150 plus 60. At omega t equal to 210, T1 will trigger plus 60, 270, omega t equal to 270. At omega t equal to 270, T2 will trigger. At omega t equal to 330, T3 will trigger. T4 will trigger at 390 degrees, 450 degrees, T5, 510 degrees, T6, like that. Similarly, while T1, T6 conducting, output voltage is VAB. Okay, T1, T6 conducting, VAB. T1, T2 conducting, T1, T2 conducting, VAC. T3, T2 conducting, VBC. T3, T4 conducting, BA. T5, T4 conducting, VCA. T5, T6 conducting, VCB, and so on. Okay, so now we will draw output voltage waveforms. Here we have line to line voltages VAB, AC, BC, BA, CA, CB, AB, AC, and so on, right? For alpha firing angle 150 degrees, what is the output voltage? For alpha 150 degrees, what is the triggering instant? Alpha plus 60. For thyristor T1, 210, 150 plus 60 at 210. Initially we assume T6 is already in conduction, so now at this instant we provide firing pulse for T1. Okay, so for T1, T6 conducting means output voltage should follow VAB. Okay, this is the reference line, second line, third line. Reference line, second line, third line. So output voltage must be like this, but it is VAB. Okay, what are the thyristors conducting? T1, T6 at omega t equal to 210, 150 plus 60, 210. I provide firing pulse for T1. Already T6 is in conduction, so that T1, T6 are conducting. Output voltage should follow VAB waveform. At 270, what I will do? We trigger T2. So load current will transfer from T6 to T2, so that T2 is the incoming device, T6 is the outgoing device. So from this instant, output voltage is VAC. Let us see. T1, T2 conducting, output voltage should follow VAC. VAN minus VCN, nothing but VAC line voltage, right? So for 60 degrees duration this pair will conduct. Then at this instant what I do? I will provide firing pulse for T3. So now incoming device is T3, outgoing device is T1, T2 is already in conduction. So by T3, T2 conducting, output voltage is BC. Okay, BC waveform. But it is VAB, VAC, next it is VBC. Then after that what we do? After 60 degrees, here we trigger T4, right? So T3 in conduction, T4 is outgoing device, sorry, T2 is outgoing device, T4 is incoming device. Let us see. T3 T4 means T3 T4 VB VBN minus VAN VBA. Output voltage should follow VBA. This is the VBA, right? So VBA, this is the waveform. Okay, it should follow, right? VBA. At this instant, what we do? We trigger T5. So outgoing device is T3, incoming device is T5, T4 again it will conduct. Why? Because each thyristor conducting for 120 degrees, each pair will conduct for 60 degrees. Now the output voltage waveform is this one. Which one is VCA? Next pair T1, T5, T6. Here what we do? At this instant T6 will trigger. So outgoing device is T4, incoming device is T6. So T5, T6 will conduct. So while T5, T6 is conducting, output voltage is VCB, right? So for 60 degrees duration, output voltage waveform should follow VCB, right? Next, what we have to do? We have to trigger again T1. Cycle will repeat. So outgoing device is T5, incoming device is T1. So T1, T6 will conduct. So output voltage VAB. See here, check. VAB must be VAB waveform. Okay. That's why I assume already T6 is conducting. So if you trigger T1, T6 will conduct, right? While T1 trigger, T6 is already in conduction, T5 will get commutated, T1 will turn on, right? Now I0, while T1, T6 conducting, output current is positive IAB. While T1, T2 conducting, output current is IAC. While T3, T2 conducting, output current is IBC. While T3, T4 conducting, output current is IBA. While T5, T4 conducting, ICA, ICB, IAB. Okay. Now how to draw load current IA? Let us see. IA, while T1 conducting, same like I0. If I0 is positive, IA is positive. While T4 is conducting, IA is minus of I0. If IA is positive, I0 is positive, IA is negative. Nothing but here only one direction. No? I0 is always positive here, right? So if T1 is conducting, IA is positive. If T4 is conducting, IA is negative. If T1, T4 both not conducting, IA is 0. Okay, let us see. During this period, see here to here, T1 is conducting. So IA is same like I0. Okay, T1 is conducting here. During this period, either T1 or T4 not conducting. Neither T1, neither T4 not conducting. So during this period, T4 is conducting. So IA is negative. Again during this period, T1, T4 both are not conducting. Again here from this instant, T1 is conducting, right? here also T2 will conduct. Output voltage is IAC VAC, so output current is positive, like this. Like this we can draw output voltages, output current, source current. You can see here average output voltage is negative, average output current is positive, power V0 I0 is negative. Negative means V0 is negative, no, current is positive, so power will become negative. Negative means power flow is from load to source. That's why three-phase full converter acts as inverter for firing angle greater than 90 degrees. Thank you.